Okay, so we're on we're on unit 5, day 7, which is factoring leading coefficients that are greater than 1. If you guys remember back to our day 6 notes, we talked about factoring leading coefficients that were 1. So now we're going to be working with bigger numbers. The essential question is going to be, how do you factor a trinomial when the leading coefficient is not 1? And just to make sure that we are on the same page, you should be on these notes right here. It says unit 5, day 6 in the, it says unit 5, day 7 in the corner right there. So let's go ahead and do a quick review. So these are not new words, these are old words, but to make sure that you understand, I need you to make sure that you're writing all the key words in. So the first word that we have is, or the first term that we have is going to be leading coefficient, which is the number that's in front of the variable with the highest degree, aka the highest exponent. Our next word is going to be constant, and a constant is a number not connected to any variable. It's the number by itself. This will be the number on the far right of whatever product that you're working with. And then the next thing that we have is factor by grouping, and grouping terms with common factors and then factoring at a greater common factor. So this was something that we did in our notes where we took out like a 2 and then we turned them into binomials after that. So let's go ahead and we'll do a quick review about when we are working with a trinomial when it has 1 in front of it. Remember, one of the things that we're doing are finding the factors of the number of the constant that you see right here, but when added together give us the middle term. And one thing I'd like you to see is that the 24 is positive, but the 10x is negative. And I want you to think about some terms that if I give them together would actually give me 24. So I do a little quick math, and I want to say that's going to be 6 and 4, because 6 and 4 times each other is going to be 24, but if added would be 10. So I'm going to have this product right here this binomial of x minus 6 and then x minus 4. And that makes total sense because if I combine two negative terms, I still have a negative term, and if I multiply two negative terms, I have a positive, so that makes sense. The next one that we're going to work with is 2x squared plus 10x plus 12. And the first thing I'm going to do is I'm going to go ahead and factor out that 2. And that should give me 2 times x squared plus 5x plus 6. So two numbers that add together that give me 6, and two numbers that are multiplied together that give me 6, that add together give me 5, are going to be 3 and 5. I'm going to take a guess at. Yeah. And both of those are going to be positive because all my products are positive, and bim bam boom, we're done with that. So let's go ahead and we'll cover the steps when working with trinomials that don't start in 1. So the first thing I need you to make sure that you do is that everything is in standard form. Again, you are talking about making sure that everything is going from greater to smaller. And once you have that in standard form, the next step is going to make sure that if we have a leading coefficient that's greater than 1, we have to factor out the greatest common factor possible. After that, we are going to multiply the leading coefficient by the constant. So we're multiplying the far left number with the far right number. And then our second step is going to be find two numbers that are multiplied to the number and make up the middle term, factor like normal. And our third step is going to be divide back out the leading coefficient and reduce. And then our fourth and final step is going to be bottoms up. So if your leading coefficient is negative, you must factor out the negative first, and you always make sure that you are paying very close attention to your signs. So let's actually do this together. And just to be clear, all this stuff is right here in your notes. You shouldn't have had to write anything down, but you do need to make sure that it's there. So let's go ahead and we'll do the first step. So first step is you need to check to make sure that you can't factor out a greater common factor. So again, we're going to take a look here and we're going to see if we can. And I'm going to say no, there's nothing that we can factor out because there's nothing that goes into 11, 21, and 2. So we are good to go. So we'll go ahead and we'll multiply the leading coefficient with the constant. And that's going to give us, x squared plus 21x minus 22, like you see right here. And then we're going to go ahead and we're going to factor like normal, and we're going to factor this bottom one like normal. So that's going to give us, if I went ahead and I did all the stuff to figure out what goes into 22 and what goes into 21, that's going to be positive 22 plus negative 1, which makes sense. Now once I've gone ahead and I've done that though, I need to divide out the leading coefficient and then reduce it. So I would do that like so. I would divide both these terms here by 2, and I should have x plus 11 equals, and that's a fraction. That's going to be 1/2 right there if you had to write that. So step 4 is called bottom up, which basically means that we're going to take the bottom number that we got and we're going to move it up. So as you can see, this arrow is taking it, and it looks like it's going to be on the outside of parentheses, but it's not. It's actually going to be moved up with the 2x that you see right here. So if you have a fraction in this, that's how you're going to do that. Alright, so we'll go ahead and we'll move on to the example. So we have x squared plus 11x plus 5. So first thing we're going to do is see if we have any common factors, and we don't. So the next step I'm going to go ahead and do is I'm going to take that 2 and I'm going to divide it by, I'm going to take that 2 and I'm going to multiply the 5 over there, and that should give me x squared plus 11x plus 10. And then I can go ahead and I can factor like normal. So again, two numbers that when times together give me 10, add together give me 11, that's going to be 1 and 10 that you see right here. And then I'm going to go ahead and I'm going to go to step 3, which is divide back out the leading coefficient. And remember that was 2, so I'm going to divide both of these by 2. And once I have that, I am going to go ahead and move to my bottom up, because I need to take this 2 that was right here and I need to move it to the 2x right there. And my final product would be x plus 5 and 2x plus 1. Let's go ahead and we'll move to example 2. And example 2 is 3x squared minus 4x plus 7. Again, I'm going to see if I can factor out anything. I don't have anything that can go into 3, 4, 7. So I'm going to go ahead and move to step 2, which is, I'm going to move to the first step, which is multiply the leading coefficient by the constant. So that gives me x squared minus 4x plus 21, because again, 3 times 7 is 21. And then I'm going to go ahead and find, and then I'm going to go ahead and proceed to step 2, which is factor like normal. And I will have x minus 7 plus, which gives me x minus 7 and x plus 3. So again, the next thing I'm going to go ahead and do on step 3 is I'm going to divide out the leading coefficient. Now the leading coefficient was 3. We've been working with 2, and now it's 3. So I'm going to divide the 7 and I'm going to divide the 3 by 3. So that will give me, 7 over 3, and that's going to be 1. But again, I need to make sure that I go ahead and take that term and I put it in the right place. And I want you guys to notice that even though this 3 became a 1, I ended up moving the 3 that was under the 7 over here, because that's where it needs to go. So if you have something that equals 1, you're not going to put the term right here in front of the variable. You're going to go to the one where it doesn't equal 1 when it's divided. So keep that in mind. Alright, and let's see. Example 3, example 4. Man, that's a lot of examples. So we'll go ahead and we'll move to example 3, and we have 4x squared minus 2x plus, or minus 30. I'm going to take a quick look and see if I can factor anything out, and the answer is that I can. So my question is, what can I factor out? What do 4, 2, and 30 have in common? Well, they have 2 in common. So that leaves me with 2 times 2x squared minus x minus 15. And just for the time being, I'm going to ignore this 2, and I'm going to just focus on what's inside the parentheses here. So I've got this 2 and I've got this 15. I'm going to go ahead and proceed to step 2, which is where I multiply those numbers together, and it should have x squared minus 3 plus 30, like you see right here. Once I've done that, I'm going to go ahead and factor like normal, and I should have x minus 6 and x plus 5. And the reason I got that is because, again, I'm looking for two numbers that when multiplied together give me 30, but when added or subtracted together give me, in this case, -1. That would be -6 and that would be 5. But I am not done yet, because remember, I need to go ahead and do the next step, which has to do with dividing the leading coefficient. And in this case it was 2, so I'm going to go ahead and divide both by 2. And after that, I'm going to go ahead and make sure I do my bottom up. And I'm going to bring that 2, because we're done ignoring it. And I should have 2 times x plus 3, and then 2x plus 5. And the reason that we put the 2x right here is because 6 and 2 were able to evenly distribute, where 5 and 2 could not. So again, that's just like the one that we had before. So we'll go ahead and we'll move to example 4 in our notes. And example 4 in our notes, just to make sure that we are all on the same page, is right here. So this is example 4. You should be seeing this right here. Alright, so again, we're going to take a quick look and see if we can factor anything out, and I can see that we can't, so we'll go ahead and proceed like normal, which is where I take the 6 and the 28 and I multiply them together. And I'll be left with x squared minus 13x minus 168. It's a big number. But I'm not done yet, because remember, I need to make sure that I am factoring like normal, so that's the next step. Which, if I went ahead and tried to find two numbers that, if multiplied together, gave me 168, but if added together gave me 13, I'm going to be finding 31, and I'm going to be finding 8. If you have trouble trying to figure out what these numbers are, like when you're trying to figure out the numbers that are in common, like so, you need to make sure that you're practicing that. Alright, so once we have this, we're going to go ahead and divide by the leading coefficient. And remember that our leading coefficient in this example is 6. So we'll do that. Alright, and step 3 is a little interesting because it's not going to evenly go into either of these numbers if you take a look. You know, 21 is not going to be evenly divided by 6, and it's not going to, and 8 is definitely not going to be evenly divided by 6. So what we're going to do first is we're going to go ahead and reduce. We're going to see what numbers 21 and 6 have in common and what numbers 8 and 6 have in common, which would leave us with 7 and 2 and 4 and 3. Now, we're not done yet because we still have to do our final step, which is the bottom up, which is where we take these numbers, this 2 and this 3, and we put them in front of the variables that we have right here. So this would be rewritten as 2x minus 7 and 3x plus 4. Alright, and our last example, which is number 5, is the one that you guys are going to do on your own. I want you to give this a shot and see if you can do it. Pause the video, and when you're done, take a look at it. If you didn't understand it, come find me in class and we'll work on it together. Alright, so this is the work that we should have been able to get from our problem. And if you were not able to, get it the exact same way that I did, come on and find me and then we'll cover it together. Now, so that brings us to our summary where you have to answer the essential question. Just as a reminder, the essential question, which you should have written in your notes, is how do you factor a trinomial when the leading coefficient is not 1?